Please welcome to the stage Engineering Manager at Octane, Natalie Parker.
Good afternoon, everyone. Hopefully you've had a nice lunch. Today we're going to be talking about cutting cookies at Octane. I'm Natalie Parker, an engineering manager at Octane. I've been here for 4 years, firstly leading a platform engineering team, and more recently a software engineering team. I'm passionate about using technology to develop great products and to empower my team to do their best work. Outside of work, I love cooking, traveling, new languages, and eating cookies, as you can see from the photo. Octane's a family of shipping and logistics technologies. We offer tailored solutions whether you're shipping a package once a week from your garage or thousands of packages a day from warehouses across the globe. Each logo that you can see represents a brand, a product that we offer that's tailored to a specific market segment. We operate at a very large scale. So we reach 500 million households annually to 250 territories and countries across the globe. We're the glue that connects retailers, carriers, and consumers. And at this scale, it's important to have really strong glue. So what's the connection with Octane and Shopify? Well, Octane's been working with Shopify for over 10 years with different partnerships and integrations across the suite of Octane products. Octane helps Shopify accelerate their expansion into new territories by providing an extensive global carrier library. Shopify helps Octane increase our user base. They're a very effective channel for us to reach smaller consumers. So the section of the business my team is focused on is the delivery options product for the enterprise e-commerce customers, the brand called MetaPack, as you can see from my t-shirt. So we offer a REST API that retailers use to provide customers with a variety of delivery options, to give them the optimal customer checkout experience, and to reduce basket abandonment. The retailers can integrate directly into our API, or they can use a Shopify app, as you can see on screen. The tech stack that underpins this product is Java microservices that run in containers in the cloud. We use database technologies such as MySQL, Postgres, Dynamo, depending on their application. And we use DevOps practices. So you build it, you run it. We use infrastructure as code everywhere, from our monitoring and alerting, all in Terraform, and deployed using automatic deployment pipelines. However, things weren't always this good. As many successful tech companies experienced, 5 to 6 years ago, we were struggling with the size of our monolith. The release process was very slow. The scope of ownership between the teams was quite blurry. So we decided to split it into more manageable components that would be owned end-to-end by the dev teams. You can see a rough representation of what we were doing in the diagram. So we wanted to have teams have full autonomy in managing their component, from the app code, the database, deployment, to observability. It was going to be the true DevOps nirvana. However, before we get to Nirvana, a quick bit of audience participation. Can anyone tell me what this is? Any ideas? Okay, it's not a great photo, to be honest. It's a boilerplate. So the term boilerplate dates back to the 19th century, when they used steel plates as templates to create steam boilers. It later developed another usage where there was a requirement to identify who made the boiler and where, because they kept blowing up and killing people. Anyway, enough geeking out on etymology for now. When we're talking about boilerplate code, what do we mean? So we're referring to code that's not specific to the business domain. It's code that is quite generic and can be reused across many apps. And as we found that when we were migrating from the monolith to microservices, we were writing the same code again and again. Even though we were already using some shared modules and libraries and all of that good stuff, there was still a lot of code required to glue things together. It was boring from a developer experience, and it wasn't a great use of time, developer time for the business, because we pretty much stopped feature development whilst we were concentrating on the migration. So we started to explore templating solutions. We wanted something that would be reusable and save time when creating a microservice. We wanted a cookie cutter, something that would give us perfect, identical cookies each time. so that we would have all of the code for the common concerns included, and we could focus on building the domain-specific features on top. We had two key goals, really. Firstly was to have a faster time to market. We didn't want to spend too much time on getting the basics set up. And secondly, we wanted to have a better developer experience, reduce the toil of writing the same code again and again. So our first iteration of the cookie cutter was just a skeleton repo with a Spring Boot starter and a Hello World endpoint. When we wanted a new app, we would duplicate the repo and do a bit of find and replace. So it was a good start. It saved some time, and we had things created from the same starting point. But obviously, there was quite a lot of room for improvement. There was a long way to go between having the copied repo and a minimal running component in AWS with all of the required observability in place. This cookie cutter gave us oat and raisin cookies. OK if you don't have anything better, but not ideal. So we started exploring other options. Instead of just copying things across, we started using the Spring Initializer tool to generate the project. So this gave you a bit of flexibility with project generation. You could specify some input parameters, such as the command I've got here. You're saying we want Java version 11, build tool, Gradle, packaging war, with some dependencies included. And it would generate the project according to those parameters. However, this was still only addressing one part of the puzzle, the Java and Spring part. We were still copying across all of the infrastructure and monitoring deployment configurations. So we were considering scripting this bit manually, but we were also looking for something better, which we found in the cookie cutter. So this is an open source project. It's a cross-platform command line utility which creates projects from templates. It's written in Python, but you don't need to know Python to use it. And it generates projects in any language. You can also have multiple languages in the same project, and you pass in variables on the command line or using a config file. There's many predefined templates already on GitHub, or you can make your own. So we chose to make our own because we had quite a specific use case for us. We wanted a cookie cutter that would cover all of the parts of the boilerplate code, which we kept writing. So we wanted it to create a Spring Boot app with Gradle that had a health check endpoint, that had the testing and deployment pipelines created, that had all of the infrastructure Terraform code for all environments, including the monitoring, logging, and alerting Terraform code, and the security scanning. So once we had this in place, it was like a cookie cutter that would give you milk chocolate chip cookies. Pretty tasty, and definitely better than oat and raisin. In order to customize it even further, the cookie cutter utility has a concept of pre- and post-hooks, a bit like Git. So these are Python or shell scripts which run pre- or post-generation of your product. So, for example, for pre-hook, we had a script which checks the input variables were the correct format and that they were valid. So one of the variables was a Spring version. It would check that there was a number, and it was also a valid version. It also checked the required dependencies were installed, such as Terraform, Docker, Git, things that we were going to use later down the line. For post-hooks, we did some build Gradle customization of the plugins. This bit, we still use the Spring Initializer to generate the Spring part of the project based on the version parameter that we input. We also pushed the project to Git, and it would test the Gradle, Docker, Terraform commands. So what we found was it was good to have some fast feedback of some of the commands that we would use in the deployment pipeline before it got to the point of being pushed to Jenkins and failing. We could actually test that those would work as part of the project generation. Which brings us on to the broader question of reliability. How did we ensure that the cookie cutter would generate an app that actually worked? So I've already spoken a bit about the pre- and post-hooks. We also had some tests in the cookie cutter which would check that those scripts did what we wanted them to do. But we needed a more extensive test, something that would test the whole cookie cutter template, including the infrastructure monitoring setup. So we decided to create a sample component using the cookie cutter. This would only have a health check endpoint, but it would allow us to test everything that the cookie cutter was doing. So here you can see a screenshot of the cookie cutter in action. This is for our sample component. You can see there's quite a lot of parameters. A lot of them are tags that we require at Octane, such as product, service, team. You can see there's some Git configuration, the Spring version parameter that I mentioned, and some infrastructure parameters. And here you can see a quick demo of what happens when you actually run that command. So you can see, to start with, it's checking the dependencies are all there. Then it's creating the template. Then it is doing the Git configuration. It's pushing everything that you created to Git. And then we've got some minimal tests that are running just to check that the health check endpoint is working as expected, and also the logging. You can see then it's checking the Docker build command. This is part of the post hook, as I mentioned, and then we're also checking the Terraform, that the Terraform init command is also working. So, was it happily ever after? Well, not exactly. After a while, we started getting an issue with stale cookies. So we found, although when we first were generating new projects, everything had the latest and greatest, after a while, we'd make an improvement on one component, maybe on a couple of them, but then we'd miss it on another, and sometimes we'd forget to feed that back into the cookie cutter. There was a few changes in team members, so some of the people that had been the original cookie cutter champions had moved on, and we weren't as good at keeping the cookie cutter up to date as we should have been. So then we'd generate a new component, and it would be missing a few bits, and then we'd have to try and work out what were the missing bits and copy them across. So we came up with 3 ways that we could tackle this issue. Firstly, add improvements to the cookie cutter first. So when we were doing an improvement, to do it first on the cookie cutter and then on the other components, which meant that the cookie cutter always had the latest and greatest of everything. We also did an audit of what the cookie cutter itself was missing to bring it back up to standard. Now, these things were a little bit of a culture change to start with, getting people used to treating the cookie cutter as a first-class citizen. But it started paying dividends pretty quickly, as when we would generate a fresh component, it was never missing anything. The other thing we looked at was how we could use the cookie cutter to align existing components with the latest standards. So, as you saw in the demo, with the cookie cutter utility, we were passing the variables in on the command line. But what you can also do is save all of the variables in a config file. So you can see here, here's an example from our sample component. You've got all of the same variables that you had on the command line, the basic tags, which in this case are interpolated, so you get a predictable Git URL. And then we've got the other parameters as well. This file we then committed to Git. So when we wanted to improve an existing project, we would regenerate it using the committed config file. We'd do this into a different directory and then copy across the bits that we wanted that had the updates in that we needed. So this worked well for some kind of changes, for example, Terraform changes that weren't app-specific. We used this successfully to migrate our infrastructure from AWS EC2 to container services, and also to add security scanning, as those were quite isolated things. What it didn't work so well was things like app dependency versions, which are very component-specific, was quite fiddly and unreliable for that sort of use case. But we were still happy with the value that it was giving us. So now we had a cookie cutter that created cookies that were chocolate with chocolate chips, maximum chocolate, maximum deliciousness, in my opinion anyway. So let's take a step back from the technical detail and review the outcomes that we've achieved here. Number 1, faster time to market. So this was one of the key goals that I mentioned at the start. We could now generate a production-ready component in 1 minute, which was great. This allowed us to focus on the application-specific logic, as the rest was already taken care of. The impact of this was that we were now a more competitive business. Number 2, better developer experience. So this was also one of the key goals that I mentioned at the start. we no longer had the frustrating toil of writing the same code over and over again. The impact was that we had happier developers. So then we also had some outcomes which weren't really planned from the start, but were still very good things for us to have achieved. For example, easily aligned components. We now had a semi-automated way to keep components aligned with the latest changes. And although what we had done didn't solve every use case, it did really help. The impact of this was that our maintenance burden was eased. Another additional benefit was that we now had a safe method for complex changes. So, as I mentioned earlier, we had a sample component that we used when we were developing the cookie cutter. But an unplanned consequence of this was that we had a new way to safely test changes in an isolated environment. So normally, we would test things in dev and int, but when you were doing certain things, such as a complicated infrastructure migration with cloud services that you couldn't test locally very easily, it was useful to have a sample component that we could test these things on. You know, sometimes, as much as you try, you end up in a mess with Terraform, and the easiest thing is just to delete it all and start again. And we could do this with this sample component without worrying that we were going to block other changes from being released because we'd accidentally broken the dev environment. So the impact of this was that we became fearless with doing infrastructure changes. And finally, we had shifted the observability and security left. So with the cookie cutter, the operational concerns and the security concerns are dealt with straight away. There's no monitoring as an afterthought, panic before launch when you realize that the logs aren't ingesting properly. And the security scanning also meant that the vulnerabilities were addressed right from the start. This was before you ended up with a vulnerability embedded in a key part of your code, which would be difficult to unpick later. It meant we could easily develop a thin vertical slice straight from the start and debug any development issues in the same way as we would with prod, with tracing, monitoring, logs, all in place. So the impact of this was that our operational standards were easier to achieve. So I'm not a Shopify application developer. I can't tell you exactly how to apply this to your daily work. But what I can give you is some guiding principles on what we learned with our cookie cutter journey. These are the best practices that I would recommend if you're developing multiple components that have similar core parts. So whether that's Java microservices, Shopify apps, or even Shopify functions that I was learning about yesterday, anything really. The first thing I'd recommend is to automate the boilerplate. Don't keep writing the same code again and again. Number 2, consider the alignment of existing components. So although this wasn't our primary use case, we derived great value from being able to use the same solution to keep existing components aligned and consistent. Number 3, treat your cookie cutter as a first-class citizen. So don't make the mistake that we made of letting it get a bit rusty and then having to sort it out afterwards. As I mentioned before, the cookie cutter is an open source project, which is language agnostic, so you can use it on many different things. And there's a huge number of pre-made templates that are already available. I'll put the links on the next slide. So thanks for listening to me talk about our journey so far. And thanks to the past and present members of teams Dorpheus and Gamma at Octane for all the work they've done on the cookie cutter. Here you've got the 2 main links, the source code and the docs. Does anyone have any questions? It's okay, we don't need to do a Q&A if no one's got any questions. Great, okay, thank you.